We're going to finish 4.4. Okay, these are properties. So this is still 4.4. These are some properties that we're going to have to use.
So do you just not come back after we graduate?
No, I can't.
You just sit here?
I don't have to teach. Okay, so we have the product property. A quotient property. And the power property. Next year, juniors can take this stuff. I don't have to.
Wait, you're going to take this class next year instead of pre-calc? So who would take pre-calc?
Students that will have to calculus in college. They could take pre-calc. Okay, so these relate to properties of exponents. So, you know, when you multiply a common base of exponents, you add their exponents. Here, if you're taking the log base b and you're multiplying two things inside the log, you can separate them, you can expand them by addition. Division, you can expand by subtraction. And then the power to power, if there's an exponent, if you have log base b of m to the p, then you have this rule that you can move this exponent out front by multiplication. I'm amused, but it is pretty different. No, you will not have to know the names of them, but we have to use them. So.
I'm sorry, on the last one,
Yes.
I just know that error.
Because if there's an exponent up here, this power property says you can pull that exponent out front. So this little p goes pulled out front to be multiplied. Yep. Yes. So what I want to do first is expand. So use those properties to expand these. And then we'll also look at condensing that. So what I see, I have two different, you could call them bases, like an exponential form. It's like they're the, well, they're not bases, but it's what you're taking the log of. There's two different numbers here. You have 10 and z. Okay, so two different 10 and z, and we're multiplying those. So we can expand them by addition. All right, and when I expand them, when I make my separate terms, this log base 10 has to go with each term. So that's log base 10 of 10 plus log base 10 of z. Okay, log base 10 of 10, now it says to expand and simplify, so simplify if possible. Log base 10 of 10 is what? 1. So log base 10, so if your base and what you take the log of are the same, they cancel and you're left with 1. So not 0, but 1. So this is 1 plus log base 10 of z. Okay, for this next one, I see 3 different things that I'm taking the log of.
Sorry, on the first one, do you have to like write like that you're canceling the times, or could you just go straight to like 1 plus log base 10?
Yeah, you could just write 1 plus. Yeah. So in this one, I have 3 different numbers I'm taking the log of, 3 different variables. On the top, what operation is between x and y? Okay, multiplication. So when I expand, what operation would I use? Addition. Okay, what about this z? What operation is there? Right now it's division, but when I expand, it will be subtraction. Each term will have the natural log with it. So natural log of x plus natural log of y. So that shows that multiplication. And then I'm dividing by z, so minus natural log of z. Now natural log is base e, and these are x, y, and z, so no simplifying to do after this. Okay. This one. So this one looks a little funny. It might not look like there's anything to do, but there is something that we will do with this one because the t is not by itself. We want it to just be natural log of one thing. Yes.
Why don't you minus L and Z from the y?
Because then it would be natural log of x over z and y over z. It'd be like z squared on the bottom. It'd be like taking it both. But what you can think is, just so you are clear what's in the numerator, what's in the denominator, is if you want to think about those being together in parentheses, they're just not necessary. Because if I wrote it in order and you wanted to write, okay, natural log, we're going back to condense this, x times, because you see a plus, y over z, this is the exact same thing as this. So even if you wrote that multiplication and then just the y over z, that's still the same thing as that. Good question. All right, so whenever you see a radical inside a log, the first thing you want to do is rewrite the radical as an exponent. So cube root is the same thing as t to what power? What power gives us cube root? 1 Good. Now I can use that power property, and when I have the number inside a log with an exponent, I can take that exponent and pull it out front, and then it becomes multiplication. So the 1/3 is no longer an exponent. 1/3 natural log. Okay, so like I said about this one, kind of with Curly's question, the parentheses here are not necessary, but sometimes parentheses are necessary, and that's when you have stuff in the denominator. So let's say you have log base 6 of t over UV. So the t is being divided by this UV, so I have to subtract u and v, but u and v, what operation is here between u and v? So I want to add between those, right? Okay, so let's just write it out. Log base 6 of t minus, because I'm dividing, log base 6 of u plus log base 6 of v. If I write it just like this, then what that says, if I were to condense it, that would be doing would be 10 over, or t over u times v. And if I have it like this, then the v is actually, would be in the top. But that's not how it is. The t needs to be divided by both, so I have to have parentheses here to make sure that what's being subtracted is actually what's being divided. So both of those have to be started. So you have to have the parentheses there. Okay. Questions about that? Okay. Now let's go the other way, and we want to condense. All right, I still have a single quantity, but I want what's in front to go ahead and move to the exponent. I now want just the log base 6 with nothing in front of it. I'm going the other way now. So what I'm going to do is I'm going to take this and move it to be an exponent. I should note here, right, that that's log of 2x. So when I go to rewrite this, I'm going to keep this 2x in parentheses. All right, so that's the main point. This is the main thing I want you to draw from this problem, is that the numbers out front can be moved up to be exponents. Now, what I'm going to do now is just simplify, because that's what we should do. I don't want to leave in negative exponent. So a negative exponent means what? What? No. Yes, so 1 over. 1 over. It means to be, fourth root would be 1/4. Yeah. So this is 2x to the 4th. Okay, and then I can go ahead and simplify that. So it's log base 6. 2 to the 4th is 16. X to the 4th is x to the 4th. So again, this is the the main thing that I care about that you know right now is that the exponent, or the number out front, can move to the exponent. The last two steps is just simplifying. Yes?
Will the number out front apply to both the next qualities?
Yes. So you could have, if you wanted to expand this, you could have done that, but you would have had to move the -4 to both. Like it would have been -4 log base 6 of 2 plus -4 log base 6 of x.
Did you multiply it? Why did you keep the quarter?
Because I'm doing 2x, this whole thing to the 4th power. So if you wrote out 2x 4 times, there would be 4 x's, right? So that's what you get x to the 4th power. So that's that same question. Figure it out. Okay. The one that you would be doing more on your test, or like your homework, would look more like this. Okay, so I don't want you to get too hung up on that simplifying part up there. So before I want to condense these, let's go ahead and move the numbers out front to exponents. Okay, so just going to take me a couple steps. So I'm going to move the 3 and these 4s. So that's natural log of x cubed plus natural log of y to the 4th minus natural log of z to the 4th. Okay, now I can condense them. So I want to condense and I want to have just one term. So one natural log. All right, and then you're adding, so those go together by multiplying. So x cubed y to the 4th, and then subtraction means dividing. Again, if you wrote it like this, those mean the same thing. So it doesn't, either way is fine. The top way just looks a little bit cleaner. Okay, any questions about that? You guys feel like you have an okay handle with those properties, expanding and condensing? Okay. Now we're going to start solving. And so with solving, we're going to have to use some of these properties to help us. Well, I guess first we're going to simplify, but we have to know the properties too, and then we'll solve. Whenever you're evaluating logs, it's always okay to put your x here and rewrite it in exponential form. But let's try to use some log properties first. It might be a little easier. So I see log base 6 and I see a 6. So I'm thinking somehow I want to get those to cancel. But the 6 isn't by itself. So like I said before, if you see a radical in a log, write it as an exponent. So that's log, I don't know why I wrote a Q. Log base 6 of 6, and then cube root, the exponent is 1/3. And then we know, what about that 1/3? Yeah, it's an exponent, so we can move it out front. So 1/3 log base 6 of 6. And now, log base 6 of 6 is 1, right? So that cancels, leaving me with just 1. So I have 1/3 times 1, which is 1/3. Good. I know that I want the natural log and e to cancel, but I have to move the 4 first. So what happens to the 4? Moves to the front. When I move it out front, what operation? Multiplication. So it's 4 times 3 natural log e, and now natural log of e can cancel, leaving me with 1. So 4 times 3 times 1 is 4. Good. All right, questions about those? Okay, now we're going to solve. So when you are solving, it should say the word solve, and you should see, a variable, something you're solving for, and an equal sign. When you are solving, you have to check your answers because logs have issues with the domain, like radicals, like rationals. Whatever you take the log of has to be positive, greater than 0. So when I solve for x, I have to make sure that if I plug it back in, when I take the log of it, whatever I take the log of, that it's positive number here. Okay, so we got to keep that in mind, meaning there could be extraneous solutions. All right. I want x that's inside a log function. So eventually I want to do the inverse of a log function, which is exponentiate. So eventually I'm going to exponentiate, and that's log base 10, so I'm going to exponentiate with 10. But before I can do that, I have to condense to have a single log. When I add, I can condense these by what? Multiplication. Okay, so I can write that as log base 10 of 5 times x minus 9. Okay. I'll go ahead and distribute my 5 now just so I can knock out one set of these parentheses here. So that's 5x minus 45. Now I can exponentiate. Okay. It's log base 10, so I need to exponentiate. I'm going to put the little 10 here just so we can emphasize. That's why I picked 10. 10 to the first. So exponentiate both sides. I do that so this log base 10 will cancel. And now I can bring this exponent down. So it's 5x minus 45 equals 10 to the first, which is 10. All right, now solve. So add 45, divide by 5, you get 11. Plug 11 back in for x. 11 minus 9 is 2. Is that greater than 0? Yeah, we're good. Okay. So you don't have to necessarily, you can type it all in with the logs in your calculator because you have log base 10 and check and make sure you get 1. But you could just take it, plug it in for where the x is, and make sure you're taking the log of a positive. All right, so that one is good. Check. Okay, I've got another one. I am going to want to do the same thing But first I want the logs on the same side, so I'm going to add log base 10 of x to both sides. And now on the left, I can condense those like I did on the last problem. So condense by multiplying. I'm going to put the x out front so it's easier to distribute. Okay, let's go ahead and distribute. So I have 3x squared minus 13x equals 2. So to get x, I have to get inside that log function. So, Julie, how can I get rid of this log function? Yep, raise it to the power of 10. Exponentiate both sides by 10. So you're not doing 10 times 2. You're doing 10 to the second power, 10 squared. Okay, so Ryan, what cancels?
The 10 and log.
Okay, so what am I left with, Ryan, on the left?
3x squared minus 13x.
Good. And then what do I have on the left, Ryan? Or on the right, I'm sorry. 100. All right. Okay. So I see that I have a quadratic. So Dorian, what do I do when I have a quadratic?
Would you factor out the x?
You could, but before I would do that, I have to do something else. When I solve a quadratic, I want to, go ahead, Carly.
Do minus 100.
Yeah, so we want to set it to equal to 0 first. Good. So factoring out the x would only be if we're already equal to 0, because you want to use 0 product property, and you have a quadratic. Okay, so now I factor or use quadratic formula. This does factor. Okay, I'm going to use 25 and 4. And it's minus plus. So my outer is 12x. My inner is negative 25x. So negative 25x, positive 12x, that gives me the negative 13x. Okay, so my solutions then are x equals, so 3x minus 25, that gives me positive 25 over 3, because you would add 25 and then divide by 3. And then x plus 4 would give me negative 4. Okay. We need to go back and check. There's 2 different places where I would have to plug x in. All right, so 25 over 3, if I go back to check that at the beginning, okay, 3 times 25 over 3 is 25. 25 minus 13, is that positive? Okay, so we're okay there. 25 over 3, is that positive? Yeah, so that one's good. Okay, then I have negative 4. 3 times negative 4 is negative 12. Negative 12 minus 13, is that positive? No. So negative 4 does not work. Negative 4 is extraneous. It wouldn't work here either. But it's possible that it might work for one and not the other. So if it doesn't work, if you see it doesn't work for one of them, then it doesn't work, okay? -4 is extraneous. So it is still a solution, but it's an extraneous solution. Since it's log base 10, you could type that in your calculator. If you tried to check -4, you would get an error because you cannot take the log of a negative number. Okay. So this is some of the hardest stuff we're doing in this chapter. Okay? You should practice it. You should practice it. All right, we're going to look at another property. The uniqueness property with logs is like the uniqueness property with exponents. If you have it, it makes things pretty simple. The trick of knowing when to use it is you have to have single terms. So it has to be log base b and log base b, nothing else. And they have to be the same base. Okay. If you have that, so these are both log base 10, log base 10, then what happens is you can drop out the log, and you just get 2x minus 3 equals 3. And that's it. So uniqueness property is easy to use if you have it available. You have to have a single term and a single term. And it has to be a log on both sides. So add 3 divided by 2. We get x equals 3. Make sure that's positive. 2 times 3 is 3, or 2 times 3 is 6, minus 3 is 3, so we're okay. Okay. So I'm going to go back to the previous problem and show you why uniqueness property doesn't work there. So I could not just cancel my logs because I have a 2. There was another term here. So you have to have just single terms. Log base b, log base b. That's it. To use uniqueness property. Okay? Alright, so we're going to look at a word problem now. If you are given a formula in your problem, you're going to use it. So like on part A, it doesn't exactly tell me what I need to plug in, but I am going to use the formula. So first of all, it tells me that I'm looking for the sales. So I'm looking for S of T. And prior to the expansion, so that's before you get started. That's like an initial start. So that's where I'm going to want T to be 0. So if you're looking for some initial quantity, something before you get started, those keywords are telling you you want to use 0. So when I go to plug this in, I'm going to plug in the whole thing. I don't have any variables here, so I'm just evaluating. So let me show you with parentheses. Let's type it all in at one time. Okay. So I want to do 40 divided, and then I need to put parentheses around my denominator. Okay? Then when I do e to the x, that should go ahead and put an open parentheses. Make sure you close it here after multiplying by 0. Okay? So double parentheses at the end. Now, you could just do that negative 0.08 times 0 in your head. All right? But you should still close the parentheses. So type all of that in at one time. And you should get 16. Okay? Were you able to get 16? Okay. And it's sales. We're selling these storage buildings, but I think they have it measured in units. 16 units. Okay, part B. How many months until sales reach 25 units per month? So I'm going to plug in 25 for S&T. Okay. You have to solve this algebraically. So there is a problem kind of similar to this on your test. You have to do it algebraically, not guess and check. You will not get points if you just do guess and check. All right, so it can look a little overwhelming, but we'll just take it one step at a time. First of all, we have a denominator. So let's get rid of the denominator by multiplying it on both sides. Okay, so let's start there. Multiply both sides by 1 plus 1.5e to negative 0.08t. So then it will cancel on the right. Okay, so then I see that, okay, I got rid of it here. And now I'm going to write the 25 in front of that so it's easier to distribute. Okay. So first step. I see my variable is in an exponent. So I know I'm going to have to do a little log of both sides, but I cannot do that until I have base e by itself. All right, so let's remove parentheses by distributing 25. Okay, so 25 times 1 is 25. 25 times 1.5 is 37.5. Okay. I'm trying to get e by itself, so subtract 25 and then divide by 37.5. So subtract 25, we get 15. Divide by 37.5. And I think that's 0.4. Okay. If you had to round, you'd want to leave that as a fraction, but 0.4 is okay for now. So this is an exponent, so the inverse of an exponent is log. So what is log base e? Natural log. So I want to do natural log of both sides. I'm going to wait to round until the end. So now I can cancel the natural log and the e. And I have natural log of 0.4. So this is just a number, but I'm going to wait till after I divide. So natural log of 0.4 divided by negative 0.08. So approximately 11 point, if I round to 1 decimal place, 5, right? So you should get. All right, but I want to know how many months it will reach 25. So between 11 and 12. So I should probably go ahead. So I'm at least at 25 and say 12 months. All right, we did that kind of fast. So go back through that. Go back through that. Make sure you understand all the algebra there. That is it for 4.4.